Good afternoon, and I'm busy here converting some of these old fairy lights from tungsten, normal tungsten filament bulbs, to LED. So this is the LED side, and the tungsten side isn't lit. I'll explain reasons why in a second. But I thought whilst I'm doing this, I might as well just quickly shoot a video and show you what I'm doing. So these are the old fairy light bulbs, and you take the shade off. This is the bulb under the shade, and you take that bulb out. This is the actual bulb. So it's these old filament bulbs. And what I'm doing is I'm converting them to LED using normal 5mm LEDs in different colours. So these LEDs are running about 3 volts, and if you put them across the mains, they will draw an unlimited amount of current and blow up. So you can't just do a straight swap for these, because these have a natural resistance and they're balanced, so that you have, say, 24 of them across 240 volts, and they're 10 volt each. So we need a bit of circuitry. And the circuitry that I've got is one of these. So this is a board I designed myself. And what you have in here is basically a capacitive dropper circuit. So your mains goes in here. It goes through a fuse, through a capacitor, mains rated cap to drop the voltage, or drop the current. And then the voltage matches the current. And then you've got bridge rectifier and a smoothing cap, and then a few auxiliary resistors for bleed resistors and stuff. But that's basically it. My first design of this circuit was actually a breadboard design, which then I got made into a proper design so that I would have hundreds of them, because I get asked to replace lots and lots of LED lights. And these are JLC PCB LEDs, which I'm sure you've seen loads of sponsorship for. Not sponsoring me though. And yeah, so that's the circuit. And that goes in the mains line, and then it goes to the rest of the fairy lights. So this is that circuit board in line with the plug. So you got the plug comes in, mains in, DC high voltage out, and it will be around about, when this is completely done, this string, it'll be about 80-90 volts across there. So it's still a high voltage. It won't stay like this, obviously, because it's a little bit of electrocution hazard. It will have a case around it, potting, sleeving, to make it safe. But that's the idea. So mains comes in, gets switched to DC, high voltage, current limited. So this is limited to about 10 milliamps. Then it goes through the strings of each LED, through the light string. And you see the flickering. I've got some flickering LEDs in here. So these ones here, they're actually a flickering green LED. But yeah, the result is actually pretty good. So to change one of these to LED, once you've got the circuit in place, you have to mark which side is negative, which is this side. Oh, I'm not doing this. There you go. So I've marked it negative on one side of the LED. I can now take that bulb out. And these bulbs are held into these plastic holders by having the ends bent down. So what you've got to do is bend the ends up, like so, and then just pull it, and the cover comes off. That's the old bulb. Don't need that anymore. We can fit an LED in there, and the LED I've got running is this one here. Always power them up, must make sure they're actually working first. And then what we do, we take note which side is the negative side, which on these LEDs, on all LEDs, the longest lead's positive, short lead's negative, and on the actual LED die itself, the long toadstooly bit on this side is negative, the short stumpy bit is positive. So we feed the LED into the holder, and then we just bend the leads, again making sure that negative's on the negative mark we just put on there. Bend the leads round, and then we cut them off. So bend that lead round to there, and cut the lead off about there. And that's the leads folded and cut. And so that bulb is now ready to go in the holder. And then insert the bulb into the holder with the marks lined up, so you know negative is negative. And you always have to do this with the power off, because the cap on that board charges up to 400 volts if you don't have any load on the circuit. So you have to have a load, and if you have it unplugged, or have the bulb unplugged with the thing switched on, you get 400 volts across here. You put the LED in, 400 volts straight across the LED, you blow the LED. So always have it unplugged at the mains, put the bulb in, then turn the power on. So now it's all connected, we can turn the power on, which is this button. Ding! And there you go. blue LED. And the old tungsten lights are not lighting because there's not enough current to light them up. So we only got 10 milliamps flowing through here now, which isn't enough for the old tungstens, but it is enough for the LEDs. And so yeah, that's added to the string, and I shall keep going. Right. Hopefully that's given you some bit of inspiration, a bit of an idea how to do these, and I shall see you later.